Hello students, in this video we are going to explore an 11th class concept, that is Bernoulli's theorem. Bernoulli's theorem, let me remind you. Bernoulli's theorem states that if we consider two cross sections in a flow of a fluid, then we can say at both of these cross sections, P1 half rho V1 square and rho G H1, some of these three terms at both the cross sections will be equal. Basically what it says is pressure plus half rho V square plus rho G H. Sum of these three terms will remain constant for every cross section. So we can apply this equation at two cross sections like this. Let me consider a simplified version of this Bernoulli's theorem. What we will do is we will consider two cross sections in which difference of height is negligible. So I will cancel out this term. Height difference is negligible. Now the equation reduces to P1 plus half rho V1 square, P2 plus half rho V2 square. Now in this equation, it is simple to understand. If we consider two cross section in which velocity at one cross section is greater than other cross section, then from this equation it implies that pressure at first cross section will be less than pressure at second cross section. Where velocity is large, pressure will be less. Where velocity is less, the pressure will be large. This can be demonstrated by a simple experiment. We have here a funnel and a table tennis ball. What we are going to try is, we will first keep the funnel vertically upward, pointing vertically upward. I will keep the table tennis ball, which is very light, in this funnel, and I will try to blow it out of this funnel by blowing air from this end. I will blow very hard, and if the ball bounces, that means my air flow was able to bounce the ball. But let's see what happens before predicting it. See, what is happening is I am blowing air, but the ball is not coming out. In fact, it stays inside the funnel. Let's try this by inverting the funnel. I am again going to blow very hard in this funnel. I am going to blow air in this funnel. But what will happen is counterintuitive to what our intuition says. Our intuition says, even if I don't blow any air, the ball falls down. So if I am blowing air through this funnel, ball should actually come out of this funnel with more speed. But what happens is, let's see. I keep this ball and I am going to blow very hard in this funnel. You see what happens is, as long as I am blowing air through this funnel, ball stays in the funnel. In spite of me expecting that the ball will come out forcefully from this funnel, it stays in the funnel, and as soon as I stop blowing air, ball falls down. So let me explain what is happening. What is happening is, when we keep the ball here and we have inverted the funnel and we blow air from this point, here the cross-sectional area is very small and we are blowing air forcefully. So the velocity of air here is large. Now the air tries to escape from this narrow space between ball and funnel. The air tries to escape from this area. Here area is even smaller, so the velocity is larger. Pressure, where velocity is larger, pressure is smaller. So at this cross section and at this cross section, if we compare, velocity of air at this cross section is small. Velocity at this cross section is very large. Here even larger. So a low pressure region is created above the ball. A low pressure region is created above the ball, and a high pressure region is created below the ball. Higher pressure pushes the ball. Lower pressure also tries to push the ball, but the force by higher pressure is larger. So a net force is exerted on the ball in upward direction, which is able to balance its gravitational force. That is why the ball does not fall down. So this was a practical demonstration of Bernoulli's theorem.